Hi there, my name is Carly, and today I will be teaching you about the physics of sound. I brought some musical instruments to help with that, but first let's get some definitions out of the way. Today we're talking about physics, which is a branch, a fancy way of saying type, of science that studies matter and energy, and how those two interact. Now, in other words, physics talks about how objects move. Physics also discusses what happens as a result of this movement. And topics in physics include light, heat, and sound. Today, we'll be focusing on sound. I'm guessing you've heard of sound before, but this definition might be a little different than what you're used to. In physics, sound is created by waves, and these waves are typically caused by vibration. That's how instruments like this violin and that guitar work. When I put my bow on the strings and pull it across them, the string vibrates back and forth, creating sound. It's hard to tell by looking from afar, but when zoomed in and slowed down, you can see the string moving back and forth when the bow interacts with the string. This vibration causes the particles around the string to move back and forth. Then, the moving particles cause other particles around them to vibrate, and this becomes our sound wave. You can see the vibration even more on a guitar, because it's a bigger instrument and has bigger strings. My fingers pull on the string, and then it starts to vibrate. When scientists like us discuss the physics of sound, we usually start by talking about frequency. And frequency is the number of cycles in a certain amount of time. Now, a cycle happens when a wave starts at one crest and reaches another. To find frequency, we take the speed of the wave. That means how fast the wave is moving. And then we divide it by the wavelength. And the wavelength is how long the wave is. Frequency is typically measured in hertz, which is abbreviated Hc. 1 hertz is equal to 1 cycle per second. In other words, if the wave is moving really fast, it has a higher frequency, therefore the sound would have greater hertz. Humans can usually hear anything from 20 to 20,000 hertz, although this often depends on factors such as age, because as you get older, your hearing isn't always as good. Anything greater than 20,000 hertz is called ultrasonic. This means the frequency of the sound is too high for humans to hear it, but animals such as dogs, bats, and dolphins can hear noises at this frequency. Anything lower than 20 hertz is called infrasonic. The frequency of these sounds is too low for humans to hear it, but animals such as elephants can hear noises at this frequency, and these sounds are how they communicate with one another. Now, each sound has a frequency and it has a pitch. A pitch is how low or how high a sound is. When we talk about music or musical instruments, we usually say a pitch is how high or low a note is, because a note is the music word for sound. You might have seen music written like this before. Each symbol is a note or sound. When we're naming pitches in music, we usually give each note a letter name from A to G, because the musical alphabet only goes from A to G. The pitch is based on frequency. If we have a higher frequency, we have a higher pitch. And if we have a lower frequency, we have a much lower pitch. The pitch of this string is A. The frequency of the string is 440 hertz. Now, remember how the frequency is the speed of the wave divided by the length of the wave? If I were to put my finger on the string, that would change the frequency because I'd be changing the length of the string. I'd be making it shorter, which would change the frequency and the pitch. The new pitch of the wave is called B, and the new frequency of the wave is 493.9 hertz. And that's all for today. Thanks for watching.